Your AI bill does not explode because one prompt is expensive. It explodes because the workflow is expensive. Huge context, long answers, repeated retries, wrong model choice, tool loops, and unmeasured evals. In this video, we will learn AI cost engineering in plain developer language, not finance theory. Practical rules you can use in Copilot, Cursor, Claude, OpenAI, Gemini, or your own AI app. The biggest mindset shift is this: do not measure only one message. Measure the completed task. If an agent reads 10 files, runs tools, fails tests, retries 3 times, and then asks a premium model to review the result, that is one workflow. The prompt may look small, but the workflow cost is not small. Cost comes from several buckets. First, input tokens, prompt, files, logs, documents, and previous conversation. Then model choice. A mini model and a flagship reasoning model do not cost the same. Then output tokens, code, explanations, tests, and summaries. Add tools like search, code execution, or file retrieval. Then retries and evals. This is why a small chat can become a large bill. Prompt price is the cost of one request. Task cost is the cost of getting useful work done. A coding agent might need planning, file search, edits, test runs, error logs, and final review. If you only track prompt price, you will miss the real budget leak. The real metric is cost per merged PR, cost per support ticket solved, or cost per successful workflow. A simple formula keeps teams honest. Input tokens and output tokens are obvious. Cached context storage matters when you store large documents or repo context. Tool calls can add cost, especially search, retribution, retrieval, or image and video tools. Retries multiply everything. Evals multiply everything again. And human review time is also cost, even if it does not show up on the API bill. Pricing changes by provider, but patterns repeat. Output tokens often cost more than input tokens because generation is expensive. Cached input can be cheaper because the model reuses repeated context. Batch or flex processing can be cheaper if the job is not urgent. Very long context can enter higher pricing tiers. Tools can add separate charges. Web search, grounding, code execution, image, audio, and video are not always just normal text tokens. Model routing is the biggest practical saving. Do not send every task to the most expensive model. Simple classification, summaries, formatting, and first drafts can use cheaper models. Normal coding can use a balanced model. Expensive models should be saved for security, architecture, tricky debugging, and final review. Think of it like engineering escalation. Not every issue needs the principal engineer first. Token budgets are like guardrails. Set a maximum input size so a user cannot accidentally paste a giant log. Set maximum output tokens so the model does not write a book when you need a decision. Set workflow limits, maximum retries, maximum files read, maximum tool calls. Track budget per user, team, feature, and workflow. When budget is close, downgrade the model, shorten the response, or ask a human. Caching is useful when the same large context is reused many times. Examples: product documentation, API schemas, repo summaries, long PDFs, system instructions, or a support knowledge base. Instead of sending the same 50,000 tokens again and again, cache them when the provider supports it. But caching is not magic. It can have storage cost and time limits, so use it when reuse is real. Prompt compression does not mean removing important information, it means removing noise. Instead of dumping 12 files and a huge stack trace, send the relevant facts. What failed, which file matters, what behavior is expected, what is the exact error. This gives the model better signal and reduces input tokens. In many cases, a structured summary beats a giant raw paste. Evals are necessary, but they can become the biggest hidden cost. If you test 100 cases against 3 models and 2 prompt versions, that is 600 calls. Add retries and judge models and the number grows again. Start with a sample. Use small eval sets while designing prompts. Use stronger judge models only for difficult or borderline cases. Most importantly, track eval spend separately from production app spend. Agent workflows have their own traps. The agent may read too many files, feed full terminal logs back into context, retry forever, or use a premium model for every tiny subtask. The solution is not to avoid agents. The solution is to control them. File limits, tool limits, retry limits, summarized logs, model routing, and a stop condition. A useful agent is not just autonomous. It is budget aware. Here are the rules that matter most. Start with a short answer before asking for full code. Route simple tasks to cheaper models. Trim context to relevant facts. Cache repeated documents and repo context. Limit retries so agents do not loop forever. And measure cost per successful task, not just cost per prompt. If you follow these rules, AI becomes cheaper without becoming dumber. Final takeaway. AI cost engineering is not about using AI less. It's about wasting less AI. Budget your tokens, cache repeated context, route simple work to cheaper models, use strong models where mistakes are expensive, measure evals, limit agent loops. That is how developers control AI costs without killing productivity.